All right, still here. Here's the second part of the video notes. So we have already covered part of 1.6. We covered solving equations. So you saw an equal sign, and we did solving linear equations, solving absolute value equations, and I also mentioned what finding the zeros meant, and that just meant you set your equation equal to 0 and then you solve. So the first part is we're going to be solving inequalities, and this is review. You did this in middle school, and you did this your freshman year. So this first part should be pretty easy, solving with inequalities, and then we're going to solve with absolute value inequalities, and that's where the tough part is going to be. But let's go ahead and get started. So again, I'm on page 37 of your notes. So we're just going to solve these. Pretty basic. You can imagine that there's an equal sign if you want, but there's inequality, and whenever I solve, I always like to draw a line in between my equal sign or in my inequality sign. And my job is just to solve for x. So the first thing we do is we look for parentheses. There aren't any. The second thing we look for, can we combine like terms? And I can't combine here, and I can't combine here. And then the third thing we look for is moving the variable to one side. And it's always best to move the little guy, is what I tell my freshmen. So we're going to move the 2x over. And I'm not going to show all of these steps, but I will in the beginning. So these cancel out. I still have 1. I still have my less than or equal to. And then I have 4x minus 1 on the other side. And now to solve for x, I just have to get x alone and move the 1 and the 4 over. So first you start by adding 1. Cancels out here. You add 1. You get 2. I keep everything coming down. Keep everything on the same side of the wall. And now to get x alone, we'll divide by 4. And I'm just going to continue my wall over here. And on this side, I have 2/4, which is just a half. I'm going to go ahead and write that simplified version, and I've got x. Now, the other thing we're going to do is how we're going to write our answer. So this is our answer written as an inequality. This is okay to write, but it's usually traditionally written with the variable on the left side and the answer on the other side. And then you just want to keep your inequality the same as it is. So if it's pointing to the 1/2, I want to make sure it points to the 1/2. So this is writing my answer is inequality. Next, I'm going to put on a number line. And this is a very simple number line. So I put 1/2. This goes back to the open and closed circle. Since it's not underlined, I'm going to put a 1/2 with an open circle. And this is saying all my answers are bigger than 1/2. But if you notice how it's pointing to the right, that's what's going to happen here. And now if I put it in a interval, you know, that was the smallest number on the left, the biggest number on the right with the parentheses and brackets, that's what I'm going to do here. So smallest number on the left, biggest number on the right. And if you notice, I got a number on the left, it's 1/2. And when this is going to the right and it's never ending, that's like us saying infinity. So the smallest is 1/2, the biggest is infinity. We always use parentheses for the infinity. And since I'm not including 1/2, since it's not underlined or closed in, I'll use parentheses here. So just the different ways to write the answers. Another example, the next two are called compound inequalities. And again, this should look familiar. But you actually have two problems. And what I have my freshmen do is just write these out as two separate problems. So there's one problem. Here's the other problem. And then you just solve, and we'll do the same thing. So I'm going to show a little bit less work. So I don't have all this like what I call prep work. I just have to get x alone. So I'm going to add 8. When I add 8 on this side, we're left with 3x. Add 8 over here, and you've got 6. And now to get x alone, I'm going to divide by 3. So I'm left with x, and divide by 3, and I've got 2. All right. Over here, same thing. I'm going to add 8. So that gives me 18. Then I'm going to divide by 3. And I get 6. So when you see a problem set up like this, this is going to say that our answer when we're done is between. And again, this is how you write between. And that's how they started out, between. And if you notice, x is in the middle. It points at the 2. It'll point at the 2. It's pointing at the x here, and it's going to still point at the x here. So here my answers are between 2 and 6. And sorry, this one should be underlined. So now on the number line, I'd put 2 here, I'd put 6 here, I would close the circle. Again, this is review from middle school and freshman year. I do an open circle for the 6. And then I'm just going to show that it's between. So I just do something like this. And then in interval notation, smallest number on the left, biggest number on the right, that's 2 and 6. Since 2 is included, I'll do a bracket, and since 6 is not included, I'll do parentheses. And just the last version is this one. This is another compound inequality. So usually when we have our answers and we have two answers, for the most part, they either point towards each other, like they did here, or they go away from each other. Very rarely for us will they go the same direction. So I just got two separate problems. So I'm going to subtract 3, divide by 2. And so I've got x is smaller than 1. And then on this one, I'll add 7, divide by 4. And so all my answers are bigger than 4. So here when I do my number line, I've got 1 and I've got 4. They're both open circles because my inequalities are not underlined. I shouldn't include 1 or 4. And here all my answers are smaller or to the left of 1. And here they're to the right or bigger than 4. So my answer written as an inequality, my answer written on a number line, and now the interval notation. So if you notice, here this was kind of like one big answer, and here this is more like two separate answers. So I'll have an interval for this, for the 1, and I'll have an interval for the 4. Again, I want the smallest number on the left, biggest number on the right. So if you start with this one, and the fact that it's going to the right means it's getting bigger towards infinity. So I'll do 4 and infinity. This always has parentheses. This is not closed, so we use parentheses. And then here, when it's going to the left, that's your negative infinity. So my smallest answer is negative infinity, and my biggest is 1. Again, parentheses, and because that's not closed, we'll use parentheses. All right? Let's just take a look at these few word problems, and then we're going to move to the absolute value on the back. So you've added enough antifreeze to your car's cooling system to lower the freezing point to -35 and raise the boiling point to 125 degrees. So there's the certain temperatures that your car can operate in and not have the engine freeze up or overheat. And those are the temperatures. So as long as the coolant remains liquid between these temperatures, you're good to go. So what we're going to do is we're going to write the inequality in Fahrenheit, given that this is here. And then we're going to find what the lowest and highest temperatures can be in Fahrenheit instead. Okay? So what we're going to do is we're going to replace C, and we're going to put them in here, because this is all Celsius based, and what we want to do is turn it into Fahrenheit. So -35. I'm going to replace C with what it's equivalent to. Because of this equal sign, it's equivalent to the 5/9, and it kind of wraps around. Oops. And then I want the 125 here. Again, we've got two problems to solve. So this is going to be our first problem. Let me put a box around it. Oops. And so I'm going to write it down here. I'm going to have to use the space I don't have enough room. And then I'll solve the other problem, which I'll write down in just a moment. So here, to get F alone, you got a couple of options. So one option is to distribute this through, which you're more than welcome to. What I'm going to do is actually just get rid of this 5/9 from the very beginning. So to get rid of this 5/9, I'm just going to multiply both sides by 9/5. So this cancels out this. I'm going to come over here. And this is just multiplying fractions. All right, so you can multiply this across, and simplify. When I did fractions, I like to simplify first. So I can simplify this numerator with this denominator by dividing by 5. And now I can just multiply across and get -63 over 1, which is -63. So right now, the lowest temperature I can have in Fahrenheit is -63 degrees, where in Celsius it was -35 degrees. And now what we're going to do is the other side of the problem. So let's see. I'm going to put it down here. So we have the other problem, which is 5/9, parentheses, F minus 32, and 125. So now we're going to get this in Fahrenheit, and I'm going to do the same thing. I'm going to multiply both sides by 9/5. This takes out this takes out this. I'm going to multiply this side by 9/5. And again, I could multiply across and then divide. I need my calculator for that. So for these, I'm just going to divide by 5 and divide by 5. And then I can multiply across, and get my answer. So if I multiply across, 25 times 8 is 200. So 25 times 9 is 225. Whoops, and I put a 5 here. Sorry, that should be an F. And now to get F alone, I'm just going to add 32. And when I add 32 to that, sorry, I'm running out of room, we get 257. So now we know what the temperature can be for us here in America, since we're Fahrenheit people. So my engine can get as cold as -63 degrees, and it can get as hot as 257 degrees, and I should be okay. All right, I think we're going to hold off on this question and move on to solving the absolute value inequalities. All right, last page. Okay, so I'm on page 38, and we're going to solve absolute value inequalities. So remember, in absolute value equations, when we had something like this, so let's see, I got my little sticky note. We created two problems. We created 2x plus 4 equals 5, 2x plus 4 equals -5, and then we would solve. Remember, anything in the bars stays exactly the same, all right? And again, the reason why we did the two answers is because when I'm done doing the math in here, finding a number and multiplying it times 2 and adding 4, I could get 5 in here, and the absolute value of 5 is 5. Or I could do the math in here and get a -5, and the absolute value of -5 is also 5. So that's why we're looking to see what if you get 5 in those brackets or -5. Okay? All right, so let's take a look. So let me read the top two because this is kind of important. When we are trying to solve a function that's not one-to-one, so absolute value, remember, this is a V shape. So I'm just going to draw some general V shape. And what we're doing is we're solving for x, all right? So what could happen is when you graph an inequality and then shade, which we did not do, you know, trying to show a picture of our answers, you can shade on the outside, and as it turns out, points out here make your inequality true, or you could shade on the inside. And if you're shading on the inside, then you're saying your solution is between your two x values that we'll be solving for. But if you shade on the outside, then you're saying it's one way or the other way, like this. So I don't know if that makes a lot of sense. Probably not, because we didn't graph absolute value inequalities, but I'm going to try to explain it here. So when we're trying to solve a function that's not one-to-one, these are not one-to-one, they don't pass the horizontal line test, we got to look a little bit more carefully, because we need to test the interval and for the solutions that make the interval true. So are the solutions between them or beyond them? And that's what we're going to do. So are they inside the 2 points or outside the 2 points? So we're going to go about this the same way. We can basically ignore the inequality and solve it once with 11. I'll go ahead and leave the inequality in there. Or we can solve it with -11. Okay, so sorry, another little interruption. I'm actually going to do this. I might think it a little bit easier. We're actually going to ignore these inequalities for now, and let's just replace them with equal signs. All right, so doing what we already did in the first part of 1.6, which was in a different set of notes. So I'm going to solve for x, and I'm going to solve for x. All right? So either way, to get x alone, I'm going to subtract 7. So over here I get 4, and then I'd have to divide by 2, and I get 2. And then I have to go over here, subtract 7. This time when I subtract 7, I get -18, and then when I divide by 2, I get, excuse me, -9. So these are my two answers, -9 and 2. So I'm not going to count these out and do this accurately. I'm just going to put -9 here, and then somewhere over here is 2. I realize that this is not the correct distance between. So essentially what's going to happen is, I'm going to grab a pencil, is if I did graph this shape, it would look like this. And what I want to do is to see, are the numbers that work in this graph between these 2 points, or are they outside of these 2 points? Are they in the V, or are they out of the V? So what I have to do is pick some numbers to check. So normally we should check all 3 sections, but for this unit we only need to check one, because it's either going to work here, and if it doesn't work here, then it's going to work on the outside. So you just need to pick one point that you can put in here, do the math pretty fast, and see if your inequality works. So one number that's really great to work, that does go really fast, is u testing 0. So what I'm going to do is put 0 in here and see if my inequality works. If it works, then I'll write my answer and I'll show you. So if I put 0 in here, 2 times 0, and then add 7, I'll take the absolute value of that, and that number is less than 11, that would be great. So start with the bars. 2 times 0 is 0. 0 plus 7 is 7. If I take the absolute value of 7, I get 7. And yes, 7 is less than 11. So later, I'm going to ask you, is the alligator happy? Yes, he is. Remember, the alligator always wants to eat the bigger amount. So the alligator right now, no better words to use here, is in between 9 and 2. And this is where the alligator likes to be, because he's getting the bigger amount. So that means the solution is between. Now, if this inequality didn't work, if the alligator wasn't happy, then he'd rather be on the outside. So right now, the alligator likes to be here. He likes to be in between -9 and 2. And the way I write that is smaller number on the left, bigger on the number on the right. It's not underlined, so I'll do parentheses. You could do it like this. This is also between. Smaller number on the left, bigger number on the right. So let's go to the next one. So 3x minus 2 with the 8. So again, I'm going to drop the inequality sign for now. And again, the only thing I change is what's outside the bars. 3x is 3x, minus is minus, 2 is 2. Do not change it to a plus. So I'm going to solve my 2 problems, same steps. I'll get different results. So first I'll add 2. Then I'll divide by 3. And if it helps, 10/3, you can divide on your calculator, but that's 3 1/3 or 3.33. Here when I add 2, I get -6, and then when I divide by 3, I get -2. So I'm going to put them on my number line. So again, nowhere in particular, this is not correct. And again, I want to see, where's the alligator happy? Is he happy between the 2 numbers or beyond the 2 numbers? So again, you can pick any number you want. You can pick -5 and put it in here. I can pick 0 and put it in here. I could pick 4 and put it in here. I just want to see whatever number I pick, if it makes the inequality work. So again, I'm just going to stick with 0, which is right in between, somewhere here. And right now, the alligator is between these 2 numbers, and we're going to see, is he happy? So put 0 in. So 3 times 0, then I'll take away 2, and we're going to see, is that less than or equal to 8? So 3 times 0 is 0. 0 take away 2 is -2. And the absolute value of -2 is 2. So now I look, is the alligator happy? Is he eating the bigger amount? And he's not. He is sad. So he doesn't want to be here. Instead, he'd rather be on this side or on this side. And so now when I write my answer, I've got my pictures. So this one says an inequality. I'm going to write it as both. So here all my answers, that's the x, are, oops, and you know what, this was supposed to be underlined, so I should have some closed circles here. All my answers are going to be less than or equal to -2, or all my answers can be greater than or equal to this 3.33. If you want to write it as the interval notation, again, then I'll have 2 separate intervals, one for the left side and one for the right side. And this arrow indicates -infinity. So I put smallest number on the left, biggest number on the right, parentheses, and since this is closed and I include -2, I get a bracket. And since this one's going to the right, that's infinity, so smallest number on the left, biggest number on the right, parentheses, and again, this is including 3.33, so I'll use brackets. All right, let's zip through these last two super fast. So again, I can't do what I did up here until it's just the bars and everything else is on the other side. So I'm going to quickly subtract my 5 over. And now I'll set up my two problems. So I'll have 3 plus 4x equals 15 and 3 plus 4x equals -15. Let's solve. All right, so subtract 3, divide by 4, and I get 3. This time when I subtract 3, I get -18, and when I divide by 4, you know, this is an okay answer, but again, if you want to use your calculator, you know, simplify it, turn it into a decimal, that's up to you. I'm just going to double check, and this is -4.5. All right, so smallest number on the left, bigger number on the right. And again, I need to see where's my alligator happy. Here, between, or beyond those two. And again, the easiest number I think to test is 0, which keeps falling between. That doesn't always happen. So I'm just going to go back to the original problem, put my 0 in, and see if this works. So I start with my bars. That's like my parentheses. 4 times 0 is 0. 0 plus 3 is 3. So when I'm done with all of this, I get 3. And the absolute value of 3 is 3, which I'll add to the 5. And when I'm done, I get 8 is less than or equal to 20. And that's true. This inequality works. So that means not only does 0 work, but any point, any number in between these 2 points. All right, so I'm going to write this as an inequality. So between as an inequality, it looks like this. It is underlined because it's underlined up here. And I'll just put the small number on the left, the bigger number on the right, and that's an inequality. As an interval notation, you know, I just have one big answer, so I just need one interval. So smallest number on the right, biggest or left, biggest number on the right. And because they're underlined, these are closed circles, and I want brackets. All right, last one, and then I'm done with your notes. I'm done talking. I'm sure you're very much done hearing me as well. So again, I need to get this problem to look like these, just the bars, everything on the other side. So I'm going to divide the -6 over really fast. And when I do that, I get 23. I'll make my two problems. Whoops, sorry. Not thinking equal sign, and I want -23. Okay, so I'm going to solve, draw my wall. I'm going to subtract 5. That gives me 18. And then I'm going to divide by 7. And that, as a calculate, gives me about 2.6. I'm rounding that number. Here I'll add 5. I'm sorry, not add 5, subtract 5. So it's -28. I'll divide by 7, and I get -4. So on the number line, here's -4. Here's 2.6. And now I want to see where's the alligator happy. So again, I think it's easiest just to test 0, which again happens to be between them. If you want to go to this problem, put 0 in. You can also use 0 here. It's up to you. But I've been doing the original problem. So -6. 7 times 0, I'll take that plus 5, and when I'm done the math, is that bigger than -138? So 7 times 0 is 0, 0 plus 5 is 5. The absolute value of 5 is 5, so now I'm moving down to here, sorry, this is all over the place. And now I have -30, and is that bigger than -138? And it is. So that alligator, or the inequality, numbers that make it work are between them, because he liked it here. This time I'm only going to write it in interval notation, so smallest number on the left, biggest number on the right. And remember, this was not underlined, so these are open circles, and when they don't include the values, you use your parentheses. That's it. So what is your homework from here? Hold on, I gotta find that page. Okay, so I'm on page 39 in your packet. What I'd like for you to do is you've got your inequalities here. The idea is to write your answer as an inequality and a number line, and it might help. So the number line meaning it just goes here. And inequality uses these signs. When you write this answer, it'll be in an interval, so smallest number on the left, biggest number on the right, and then is it parentheses, brackets, and again, your number line. So inequality, inequality, and then you have your two absolute value inequalities. So these are pretty much set up. You just have to, again, do 4x minus 9 equals 27, and 4x minus 9 with negative 27. And then the same thing here. So your homework is page 39. That's it. I think there's still